We're going to sample the 10-metre transect. Down here, up to the end of the riffle. Net down on the bottom, and we want to, it's a standardised sampling done everywhere this way in Australia. We want to really stir the bottom up, move it up, keep it pretty close to your feet while you're stirring the bottom. Really get those feet going and lift those rocks.
Not a bad workout, that. And twist, twist, and sample the river, sample the river.
That's right. 10 metres. I'll leave the net there. You might
give us a go.
Take over and have a go. That's the way. Get those feet going. Keep the net pretty close to them. Really stir those bugs off the rocks.
I know you're down there. Come on, you critters.
You're going to be a qualified sampler shortly.
Come on, come to the laboratory.
Maybe every once in a while, just lift the net out and wash the stuff that we've collected down to the bottom. Right, the edge sampling requires a slightly different technique, but we still do the same 10-metre transect, either in 110 or a couple of 5s or a 3 and a 7 or something.
And the water's not moving so fast here?
No, much slower, and in the vegetation overhanging. So we need to be pretty vigorous up against the bank, through that vegetation, trying to get as many of the bugs out of the edge habitat as we can. Okay, and again, wash your sample down.
All right, here we go.
Like you go. Make sure you keep the water going through the net, otherwise the bugs will just swim out of it.
They haven't seen the best of me yet. Come on, you bugs.
Good little backwater, this one, not much flow. Different sort of bugs from this kind of habitat.
Okay, Vince, this sieve has the same mesh size as your sampling net there, so if you could empty your sample into there.
Yeah, we'll grab it in a fistful and turn it inside out.
That's it. And we'll just wash it down to remove any material still on the net. And you could just check that with the forceps and pick off any remaining bugs on the net.
Use the forceps, Luke. Is that a bug? No.
Any large stuff in your sample, like rocks or twigs.
Or beer bottles.
Rinse off to remove any...
There's nothing on there?
Any bugs that might be attached to it. Okay, we'll just pour this through the sieve. Then we can transfer this to our sample container.
Very good for the skin too, I understand, so. Very good for your hands.
Lovely.
More water?
More water. This here will do. Just pour it in there like that.
Okay.
And there we have our sample. All we need to do now is add preservative and take it back to the lab.
Otherwise it'll go off like a good party.
Worse.
When you've collected the samples and preserved them, they can be stored for some time before you're ready to sort them. But remember, because we're working with formaldehyde, they must be stored in a room with external venting.
Damn! I love the smell of formaldehyde in the morning. Smells like, I don't know, sampling.
Before handling, you should thoroughly wash the formalin from the preserved samples inside a fume hood. And again, make sure you use a 250 micrometre mesh net.
Okay, so first we need to distribute the sample evenly over all those 100 cells in the box. And we do that pretty thoroughly. That's a pretty good go at that. The next thing we do is select the cell that we're going to subsample, and we use that using a pair of 10-sided dice.
Oh, I'll do that. 88! Two fat ladies! 88!
That gives us the cell we're going to look at, and that's 8 and 8. That's this cell here, and that's the one we'll suck out to have a look at first. So having chosen the cell, we take the contents of that cell out using the high-tech spoon method first up.
I've heard of that method.
So we always get, for laboratory sorting, 200 animals out of the samples, and we stop in the cell on which we get 200. And when we've got as much out as we can get that way, we take the rest out with a vacuum flask, if you want to do that for us.
Into that cell?
Cell number 88,
That's
the one
it
you
there?
chose. That's
Yeah.
the one. Right down to the bottom and get all the material off the bottom. That's the way.
And then, of course, we write everything down.
That's right, but don't forget there's another way, and you must check the AUSRIVAS website to see which is the correct method for your state.
From my mental state.
Well, for live picking on the site, if we're not taking things back to the lab, the first thing we need to do is screen the sample and take all the large stuff out so that the animals are a bit easier to see. Give it a bit of a wash to make sure there's no animals on it as you lift it out. And throw that away. Just make sure that if you've got a lot of sample, that you don't put too much in a tray at one time, because you won't be able to see things very easily. And then when you've got the tray cleaned up a bit, you need to scan the tray for the different kinds of animals.
What about the really little ones?
Those ones as well, and some of them might be hard to see, and if you are having problems with that, you might need to use some magnification like a jeweler's visor. So as you pick them up, we put them into 70% alcohol, and we want to pick up as many different kinds of bugs as we can, up to a maximum of about 200.
200?
And we want to sort for about 60 minutes. That's either...
Or an hour, whichever comes first. Well, there's quite a few bugs here. This is not going to take an hour. How do we know when we got to 200?
Well, there's a couple of ways of doing that. Normally we either keep score on a sheet, count in lots of 5, say, or use a tally counter is a good way to do it.
And don't forget to fill in the field sheet, Vince.
And then that's it. We're done.
Remember the flow chart. Well, we're going to take this sample back to the lab to sort. So the last thing we need to do is to make sure that we've preserved it properly. And needless to say, the rules of chemical handling apply. We're going to preserve this with formalin, which is a noxious chemical, making it up to about a 10% solution. Make sure that the lids are screwed on tightly, wearing gloves so that you don't get it on yourself. And best to either have it stored in the back of a vehicle with a separate cab like this one, or in an airtight container.
Righto, away we go then, hey?
When you've got it in the vehicle, it's a good idea if we make sure that the vehicle's packed carefully.
Oh, yeah. I was going to put my seatbelt on.
Good.
So what's happening here then, Richard?
Well, we use a tally sheet for recording the identities and numbers of all animals in the sample. And we identify them all to family level, except for the worms, mites and copepods.
Oh, we don't worry about the copepods.
Not to that extent.
And chironomids we identified a subfamily.
Yeah, I was just thinking that.
And once we've got the sample, preferably we'll archive it in the state or territory museum for future reference. And of course you need a separate database for the physical and chemical data and another for the biological data. And when you're preparing the data for entry into the AUSRIVAS model, you need to use the standardised codes for the habitat data, which are separate for each of the states and territories, and then also the ones for the bug data, which are the same for all of Australia.
So, Richard, what have we discovered?
Well, after we've run the data through the AUSRIVAS model, it's shown us that the site's not quite as good as we might have liked or might have expected. There are a few things missing, a few of the caddisflies and a few of the stoneflies. And so instead of it being in really good condition, it's a bit down from that. And when we colour it in on the map, we would colour it maybe, instead of blue, meaning it was in good condition, we'd colour it green, showing that it's not quite as good as we expected.
So in the end, we'll have a big map of Australia with a colour-coded system of how healthy our rivers are.
That's what we're hoping to do.
If we compare the invertebrates that the AUSRIVAS model predicts should occur at a particular site with those actually found by field workers, then it allows us to quantify the state of the river's health. So each sample completes another piece of the picture. And because the model identifies absent fauna, it provides clues to the types of impacts occurring at the site. And when the data has been collated and analysed, we can begin the enormous task of restoring the health of our rivers.